This unit adds on what we looked at in our last topic of compounds and bonding and extends it to help us know more about how these compounds interact with one another. It is a focus on attractions and forces between molecules, which we would call intermolecular. In terms of the AP test, this covers almost 1/4 of the content by the time we get through all of the different kind of nooks and crannies of what we will cover. In the last unit, when we were focusing on chemical bonds, be them ionic, covalent, or metallic, we were looking at the chemical properties. When we break or make chemical bonds, we change from one substance to another. Energy is required and released as we first break and then make some bonds. If we have a physical change, that means we're starting and ending with the same chemical substance. We are just rearranging how those particles are connected to one another or how those particles are attracted to one another. In those instances, we aren't breaking bonds, but there is an attraction between the separate particles. The bond within or the attraction within a molecule would be a bond or an intramolecular force. Here we are focusing on inter or between two molecules, intermolecular forces. Intermolecular forces are often abbreviated as IMFs, and depending on what type of compound or molecules we have, the IMFs that we experience are different. The attraction between them is significantly weaker than a chemical bond. Ionic, covalent, and metallic bonds are all fairly strong. All of the IMFs that we'll look at here are much, much weaker. But we can still compare, contrast, and predict strength based upon the amount of charge on each of the particles that are attracting each other, which is based upon polarity, either permanent or temporary, and based upon how close those molecules are to one another. So Coulomb's law still applies here. When I have a pure substance made of covalent compounds or molecules, there are three types of IMFs. We'll first introduce those IMFs and then have videos that go into more detail with some practice problems. All compounds, all molecules, all particles experience dispersion forces. Dispersion forces exist between particles because of movement of electrons, and they're especially important in nonpolar molecules. In dispersion forces, we've got temporary polarity holding one molecule next to another. A polar molecule has a partial positive and partial negative end. That positive and negative end would attract something else with a positive and negative end, and those two positives and negatives we can call dipoles. When we have one dipole attracting another dipole, we call that a dipole-dipole attraction. There's special instances of dipole attractions in which hydrogen is bonded to specific elements that are very electronegative. They are nitrogen, oxygen, and fluorine up in the top right of the periodic table. And when hydrogen from one molecule attracts the NO or F on another molecule, we have a special IMF called the hydrogen bond. So on each of these, we're looking mostly like what is the thing that would attract another thing? Nonpolar to nonpolar, polar to polar, or an H to an O, N, or F, and an O, N, or F to an H. When I have a mixture of substances, those particles can still mix. Remember, a mixture or dissolving something is a physical change because we still keep the same chemicals with their same identity. When something like salt dissolves in water, it does so because there's an attraction between an ion to the polarity of water. We call that an ion to dipole attraction because it's an ion to a polar compound. When we place an ionic compound in something nonpolar, the ion could be attracted to the nonpolar compound and force some polarity on there. That would be an ion to induced dipole force. When a polar thing is mixed with a nonpolar thing, then we would have a dipole for our polar thing and an induced dipole for our nonpolar thing. Nonpolar compounds have induced dipoles very similar to the way that we can stick a balloon to a wall and make that attraction temporarily by kind of moving the electrons around. That's what an induced dipole is, a temporary arrangement of charge that allows my nonpolar thing to attract to something else. We'll go into more detail with each of these and see specific questions and applications of the different types of intermolecular forces, as well as connecting with Coulomb's law to understand the strength.